everybody. Welcome to this session. Um, Now that it's 4:30, I'd like to introduce our speakers today. We have Zareen and Sayonita Ghosh Hajra from James Madison University and Sacramento State University with their presentation, Supporting Students' Engagement in Community-Based Mathematical Modeling.
Thank you. Is it Anna? Anna? Anna, thank you. Thank you for this opportunity to present today on our work with undergraduate students on community-based math modeling. In today's presentation, we will discuss what is community-based math modeling and share an example how we used it in the context of a calculus course. But this could be easily replicated for other math courses, especially in differential equations course. Now I will pass on to Zareen to share some background on community-based math modeling.
Thank you, Shainita, and thank you, Anna. Hi, everybody. I'm Zareen Gulaga, and I am an associate professor at James Madison University. So my background is in mathematics pedagogy. I teach pre-service teachers to become middle and high school math teachers. And so I'll share a little bit of the background for the work that we did. Let's see. Okay. So the overview is that we engaged our students in Shainita's class, and basically our goal was to have the students engage in a math modeling cycle. And we used the definition of math modeling as presented by the GEM report, where the students engaged in identifying the problem, making assumptions and identifying the variables, engaging in the math by analyzing and assessing various solutions, checking the feasibility of those solutions, reviewing each other's work, and then revising, and then going through iterations of that process. Now, the community-based math modeling part has that community piece in that. And so as the students pose the math problem and they come up with solutions, our goal is to connect mathematics to a social context that is relevant to the students and their lives. So we wanted the students to bring those questions up by themselves, to notice the communities or the spaces within which they were embedded. And the goal of community-based math modeling is to help students develop awareness about their communities, about the systems within which they're embedded, to use mathematics to ask and then answer questions, and potentially use mathematics to take action, not only to improve their lives, but also to improve their communities. And so if you look at these two cycles here, the cycle inside is the math modeling cycle, where students pose a math problem, and then they try to use mathematics to answer that question, to check the feasibility of that solution, and then go through that process. The cycle that you see outside is that community-based part, where the goal is to start the students off by building awareness about their own lives and the systems within which they're embedded and their communities, and eventually to take some sort of action in their communities using mathematics. So the goal or the aim of community-based math modeling is to promote equity and develop civic empathy, and also to develop tools using mathematics to take action within their communities. So we want the students to facilitate connection between the mathematics and the world around them. We want to foster engagement by encouraging students to solve complex problems. And we want them to analyze and critique the solutions that they're coming up with and how they may be implemented in the world around them. And then we also want the students to develop civic empathy, notice the world around them, and take action using mathematics. And so this idea to promote equity and develop civic empathy, this whole community-based math modeling is built on the framework that includes mathematical modeling, culturally responsive mathematics teaching, and civic empathy. And the main idea is built on Paulo Freire's idea of critical consciousness. By engaging students in problem solving that is not just devoid of context, we want to encourage the students to become aware of the systems within which they're embedded and use mathematics as a tool to bring about systemic change. And if not taking action, at least start by developing an awareness of the systems within which they're embedded. And so one thing that was, I guess that might be new for when you're teaching a math course is that we didn't just use math standards or math learning goals. We also used social justice standards or social justice learning goals. And I'm going to put this link in the chat. You can go to this website. It is called Learning for Justice, and it has 20 different social justice oriented learning goals within 4 strands of identity, diversity, justice, and action. And I'm going to share with you the learning goals that we used. So we used 3 of those 20 social justice learning goals in addition to our content, which is mathematics learning goals. So students will express comfort with people who are both similar to and different from them and engage respectfully with all people. Students will respond to diversity by building empathy, respect, understanding, and connection. Students will plan and carry out collective action against bias and injustice in the world and will evaluate what strategies are most effective. So after we have gone through the actual work that our students did, in the end, we'll share which one of these goals were actually met based on our the lesson plan and the activity that we planned and implemented. So with that, I'm gonna move it over to Sayonita so she can provide the details of the activity.
Thanks, Zareen. Now I will provide an example how community-based math modeling was used in a calculus course with 25 students. And I used this in a summer session. We call this activity the photo project rate of change in the community. So the class met 4 days a week for over 2 hours over a period of 6 weeks. So the sessions were longer and the activity had 3 parts starting from day 1. This 3-part activity provide the students with time to engage in the low flow task, which I will share in a moment, activities 1 and 2. And then once they had grasped the concepts of rate of change in calculus, then they completed the final photo activity 3. So the first activity, we call it If I Knew, Then I Could. This activity served as an icebreaker activity, like a get to know you activity. This was introduced on day 1. One of the learning outcomes for students was to identify quantities that are changing over time. Another was for students to be able to pose real world questions and make assumptions. This activity initiated conversations and helped students grasp the concept of a quantity. Here a quantity refers to a measurable attribute that can be expressed numerically, such as length, area, volume, temperature, price, size of a population, etc. So here I am showing you 3 images. These are taken from areas nearby the campus. One is the showing a section of the riverbank which is filled with trash. Another one is a flooding near the Guy West Bridge. That's a bridge near campus. And the last picture is showing an aerial view of townhomes in the Sacramento region. So the class started with students randomly selecting one image card from a stack of image cards, and there were a couple of more featuring images from the local community. And then they were asked to identify quantities that change with time and to discuss how those quantities relate to the photo situations. First, students were allowed to think on their own, and later they were instructed to find students with similar cards and again discuss the if I knew, then I could say something about sentence. So next slide, please. So this activity involved not only individual work, but also group collaboration. So they shared ideas, they expanded onto other groups' ideas. So this was activity 1. And now I will share some examples of student work. So this are some examples of student work on the housing and smog picture they were analyzing. They identified quantities such as house prices, number of houses or people, population. They also asked some questions such as how does the population change over time when they are using the number of houses? So these are some of the questions that came up on the first day. And then we had a good discussion on what quantities mean. On the second day, we did the photo activity 2, which we call My Photo, My Questions, Exploration Through Imagery. So students went outside the classroom to capture pictures around campus they found interesting, but with a focus on exploring quantities that change over time. The goal of this activity was for students to select their own areas of interest or images they are interested in exploring further and developing questions around this context. Next, I will show you the detailed task that was shared with students. So as I mentioned, students took a picture around campus. Then they were asked to write, describe the picture using about 50 words. And then they were asked to identify important quantities and discuss how they relate to their photo situation. They also completed the sentence, if I knew, then I could do something about this. And then they were asked to write, generate 2 questions that they want to examine. They wanted to examine related to their context and also what kind of data they would need. And after that, they were asked to gather some data sets, and some sources were provided to them where they can look for data. And then there was an individual component to this was they were asked to review at least one of the group's posts and then provide some noticings and wonders about the group's questions and the gathered data. And here are some examples of students' work. The first one was Rosemary Bush Growth Project. Here, one of the groups wrote that they went outside the classroom and found rosemary bushes. And they wrote, I have a bush at my house and use it in my cooking a lot. So I started thinking about what we could do with it. The group further wrote if we knew what year this rosemary bush was planted, as well as having measurements for this bush since it was planted, then we could determine the rate of growth of the rosemary bush over time. Another group observed something about campus and wanted to explore the changing demographics and ethnicities in the campus. So they wrote, if I knew the demographics for the previous 6 years, I could be able to see a slight change in ethnicity and age. The quantities we will use is the number of students each year of a particular age and the number of students each year of a particular ethnicity, which relates to how diverse the student population is. And after students presented their group, posted their group's work, these are some individual students' review. So one student who was reviewing the Rosemary Bush Growth Project wrote that this was a cool project from you all. I'm very intrigued of how you all did this by measuring the height of the plants and calculating the different stages of heights. I have seen that bush around and never really thought of it that way. I now will go around and think of the rate of how bushes or any plants be growing. So here they expressed excitement and curiosity about the project related to measuring plant growth and how they will be thinking about plant growth from now on. The second reviewer wrote about the changing demographics project. They said, I like the idea of analyzing the different ethnicities of students attending this institution is a good example as it is one of the most diverse campuses. You provided a nice data set and I can see some of the groups change over time. I wonder if there are any events that cause different ethnic groups to be more common on campus versus others, and maybe the festivals and celebrations have something to do with it. I know that every semester we have a cultural heritage fair for Pacific Islanders, yet the rate of them attending the institution is low. I wonder why that is. So here the reviewer values the analysis of student diversity, wonders how events influence enrollment, trends, and questions why the specific group enrollment remains low despite different programming offered each semester. And this is a good example how students are noticing about their surroundings more. And the third activity, so the first two were done in day 1 and day 2. And this was introduced, the third activity was introduced later in the summer session after the rate of change was covered. So here, based on the day 2 activity, students were asked to revisit their questions from the photo activity 2, rewrite their questions to align with the idea of rate of change. Then they were asked to, using an Excel spreadsheet, calculate the average rate of change over different periods from the data, and then sketching a scatter plot from the data and finding a reasonable polynomial function that fits the data. And then they were asked to use 2 different ways to calculate the instantaneous rate of change and then writing a sentence that explains the meaning of the number, including the units in the context of the data. And they were also asked to write a summary of their conclusion. So that was done in the group. So task 1 through task 6 was for group work. And then task 7 was to review at least one of the other group's posts individually and post their own noticings and wonders about their group's posting. So these are some of the example of student work. So the first one was the work of student on the rosemary bush project. So they estimated the rate of growth of the rosemary bush and they worked together as a team. They come up with an answer and they used 2 different ways to explain their answer. They verified their answer. And this one was the activity 3, which was there's another one on the redwood tree project. They investigated, they started with one project, but since they could not collect the data, they looked at they looked at the number of people that visited the campus planetarium between 2019 to 2021 and 2021 to 2023. And they again used 2 different ways to calculate the instantaneous rate of growth. Now, this one, the one we are sharing right now, is an example of student review on the projects that they did. So one student various students mentioned about noticing different things about the work itself and share questions that other could learn from. So reviewing the planetarium visit project, one student commented, it's interesting to see the large plummet in visitors in 2020, which is most likely due to COVID. On a graph, luckily, the average amount of visitors returned to its original amount and is even expected to surpass it this year. In this example, the student tried to make sense of the analysis that there was a decrease in the number of visitors in 2020 because of the widespread of COVID-19. Similarly, the next quote was from a student who mentioned that there is another way of looking at the mean and looking at the average in the first method. So they gave some more ideas how to do the analysis further. So these comments kind of highlight that students were able to experience how peers from their own class were able to develop a variety of questions and answer them using calculus. When reviewing peer work, students were able to compare multiple ways of organizing data, connect results to context, and offer alternate techniques. And these experiences provide a low floor entry to select their own context and mathematize them. Now I will hand it over to Zareen to guide us through the connection of math to life.
Thank you, Sayonita. And so the goal for us having engaging our students in community-based math modeling was that students should be able to make choices where they themselves are posing problems based on what they notice. So that gives them agency, and that also allows them to make their own connections between the math and their own lives. And so that was our goal. Community-based math modeling it allowed our students to get a chance to engage in mathematical modeling and apply mathematics that was learned in the class to contexts that they themselves selected. So this agency it is also connected to their math identity, where they become the actual doers of mathematics. They themselves are posing the questions and then using math to answer those questions. And so earlier we shared the 3 social justice goals that we wanted to meet when we designed and implemented the activity. So we were able to meet the first 2 goals because students were able to review each other's problems and the solution strategies. They were able to respectfully engage in dialogue, whether they agreed or disagree, or had ideas about ideas that might be similar or different from their own. In addition, students were able to look around in their own community and develop an awareness of the spaces where they live. Now, we also noticed that their engagement or the questions that they picked were surface level. They were not very deeply ingrained in systemic injustices. And also when it comes to taking action, we saw that the students were not necessarily planning to take action using that math to take outside of the classroom. So that scope was pretty limited. So in the future iterations, we would focus on that taking action piece where the students would engage in the community-based math modeling cycles, but also engage in taking action, noticing systemic injustices when they're thinking about the questions that they are coming up with and what they're going to use math to answer. And so that taking action piece, how we can support our students in using mathematics to answer social justice focused questions.